This video is on the domain of recursive functions. By the end of this, you should be able to figure out when you look at a recursive function what its domain is. So first, let's define domain. Domain is what numbers can the x be. That's one way of defining it. Another way of defining it is the values of x that are defined. Okay, so let's look at this recursive function right here. Let's use that to fill in this table of values. So on the left side, you have your x's. On the right side, you have your f of x, which is basically your y. Okay, and looking at this, I know when x is equal to 5, my f of x, or my y, is equal to 2. So x equals 5, y equals 2. And now this says that for every other x after 5, so for when x equals 6, 7, 8, 9, for every x after 5, my y, or my f of x, is equal to the y value right before it plus 4. So this one right here is equal to your 2, the one right before it, plus 4. So 6. This one right here is equal to 6 plus 4. This one is equal to 10 plus 4. And this one is equal to 14 plus 4. Okay, there we go. So what is the domain for this particular recursive function? Well, before I do that, let's put this onto a xy coordinate plane. So 5, 2 is right here. Okay. Then you have 6, 6, 7, 10, 8, 14, 9, 18. Cool. Let me ask you something. When x is equal to 4, what would the y be? Or let me ask you a different question. How about when x equals, I know when x equals 5, my y is 2. When x equals 6, my y is 6. What happens when x is equal to, say, 4? Now, some of you might look at this graph right here, and you might say, oh, well, I know that. Ooh, pardon me. Oh, just looking at this, I can tell that. I can put a nice little line through all of this. And so therefore, when x is equal to 4, my y is right here, which would be -2. But the problem with that is that this black line is not my graph. My graph is these orange lines, or these orange circles right here. I know when x equals 5, y equals 2, I know these points because they are defined by this recursive function. But this recursive function is only when x is equal to 5 and numbers after 5. When numbers for x after 5. This technically doesn't define when x is before 5. When x is equal to 5, this is my equation. When x is bigger than 5, this is my equation. Nowhere here does it tell you Nowhere here does it define when x is smaller than 5. So x values smaller than 5 are not in its domain. It is not defined. So I know that my domain is going to be when x is bigger or equal to it's bigger than or equal to 5, because it literally doesn't define it for numbers before 5. But there's one other thing to take into account here. So once again, I know these values. How about 8.5? When x equals 8.5, what would be my y? Well, x equals 8.5. Well, that is definitely an x that is bigger than 5. So I would use this equation. Well, in order to use this equation right here, I need to know what my x equals 7.5 is equal to. I need to know 1 before it. And 1 before 8.5, I would need to know when x equals 7.5, what was my y then? Well, in order to figure that out, because it's not here on this table, in order to know that, I would have to know when x was 6.5. That's also not on the table. And I would need to know when x was 5.5, etc. And in order to know when x was 5.5, what was my y, I would need to know what x is equal to 4.5, what was my y. And now, once again, we're outside of the domain. There is no y values for x smaller than 5. So looking at this recursive function is only defined when x is equal to or bigger than 5, but only the integers. So it's only integers that are integers of x bigger than or equal to 5. So 5, 6, 7, 8, 9, 10, 11. Those are the x's that are defined by this recursive function. Anything in between these x's are not defined, because you need to know the value 1 before it in order to be able to find it. Let's do one more example here. Let's say we have this right here. So let's use this to make my table. So we have a g of n over here, and on the other side we have an n. Okay, so when n is equal to 1, when n is equal to 1, I know that this is equal to -7. And for every n bigger than 1, I use this equation, which is your previous y times 2. So when n is equal to 2, this is -14, because -7 times 2, -14. For my next one, it is -28, -56, -112. Okay, pause the video here. Determine the domain for this recursive function. Hit play when you are ready to check your answer. Okay. So here, your domain is integers when n is bigger than or equal to 1.